Isotopes of a single element also differ in their rate at which they change phase from a solid to a liquid or a liquid to a gas. A molecule in the gas phase moves randomly and at higher speeds than the same molecule in the liquid phase. The liquid phase, in turn, moves more randomly and at higher speeds than the same molecule in the solid phase. Heavier isotopes are less adept than the lighter ones in moving at rapid movements. At a given temperature, when molecules have a certain amount of kinetic energy, molecules with a heavy isotope are less likely to evaporate, change phases from liquid to a gas, or melt, change phases from a solid to a liquid, and more likely to condense, change phases from gas to liquid, or freeze, change phases from liquid to solid. Higher temperatures stimulates the motions of all molecules, and a greater percentage of those with heavy isotopes cross the threshold to change phases. The element oxygen has 3 stable isotopes. Oxygen 16, which is 99.76% of all oxygen, oxygen 17, which is 0.04%, and oxygen 18, which is 0.2%. Water that has the light oxygen isotope is more likely to evaporate than water that has the heavy isotope. Water vapor thus has a lower ratio of O18 to O16, the delta O18, than the liquid water left behind. Conversely, heavy water is more likely to condense than light water. Taking the average delta O18 value, or a signature of ocean water, as a reference point and setting it to 0, water vapor in clouds over the equator has a delta O18 signature of minus 14 parts per mil, meaning it is more depleted in the heavy isotope than seawater by 1.4%. As the clouds drifts to cooler climates, some of the water precipitates. This rainwater is enriched in the heavy isotope, higher delta O18, and the water vapor that remains in the cloud is further depleted, lower delta O18. Additional precipitation events further deplete the clouds of heavy isotope, until the snow that falls accumulates near the poles may have a delta O18 of about minus 40 parts per mil. All water molecules become agitated as temperatures rise, and a larger proportion of the heavy water evaporates, and the liquid is less depleted of the light water. Therefore, higher temperatures tend to minimize isotope discrimination.